Hey folks, today we are going to talk about Reddit discussion threads. You may have come across this when you're writing something really deep in Reddit, not just deep in meaning, but there's like 10 or 20 levels to Reddit discussions. In fact, we'll just show you how that looks like. And you get up to 10,000
This is not us, by
levels.
the way. Someone else has done this.
Yeah, but you might have also faced this in Twitter. Twitter is famous for threads. And the best part about threads is you can branch out of any comment. So today we are working on that system design. Let's go. Firstly, let's figure out what Reddit looks like. It's got a post. You have the capability of posting. That's one thing.
Commenting.
Yes, absolutely.
And likes
that's
on posts and
likes.
comments.
Okay. I think we can share also, but we won't maybe look into this. Anything else?
So folks, we know that Reddit is a huge system, but as the series is about small specific problems, we are going to be focusing only on the leveling of comments. Like if there are, say, n level of comments. Interestingly, Gaurav and I was saying that how many levels are possible, that we saw somewhere that even 10,000 level of comments is possible, which is crazy, right? So
Yeah.
that is the specific problem that we are talking about.
So I'm just getting rid of things that we are not very interested in, like sharing, because that's a URL share. So that's not something we're looking into. Neither is profiles, something that we are looking into. If you are looking for how profiles are created, maybe you can look at one of the previous system design videos. The link is in the description. When it comes to metadata, again, this is not something that is super scary for us. Reddit is not like YouTube where it's got a heavy video or something. It's just text and limited in size. So I'll get rid of this also. It's not a challenge. Likes, comments, and posts. The thing that you need to do after you watch this video, that's it. Comment. Like, oh, I should get share back.
Very
But
subtle.
how do we work on this? I think the best way to start is to visualize it. We have a post.
So we start thinking about what is the difference between a post and a comment. How are they different? Because within post also there can be many comments, and within a comment also there can be many comments, right? So what is
Yeah.
the key difference between post and comment? If you think about that, then that is that above a post there can be nothing, right? So if we think of this, I guess as Gaurav is drawing, he is very good with drawing. He is trying to draw a tree-like structure, right? So there is
Yes.
going to be no parent of post versus both of them can have children in very simple terms.
Yeah. The parent here is, if you even want to draw a parent, it will be blank or null. And then you have these comment objects, which are many in number. They can be really deep and they can be really wide also. So I'll just draw the arrows to make it obvious. Look, this comment has a lot of activity in it. Maybe it's a very popular comment or a very controversial one. Both work on social media. Or it could be like really deep. Like you see over here, if you start from this post, you go here, you go here, you go here, and you go here. So there's a lot of depth. People are answering the same. This would be called a thread. So I think graphically, Keerti, this is what it will look like.
Yep, exactly. As Gaurav said, so there's going to be a depth associated with everything, right? Let's talk a bit about how are you going to identify a particular comment in this tree-like structure. Is depth enough, by the way, something that you can think about? Do you think depth is enough? Like, because all of these comments, this 1, 2, 3, 4, 5, they have same depth, right? Similarly,
Yeah.
these three have same depth. So is depth enough? Obviously, the answer is
Yeah.
no. So what
No.
else can we have?
Yeah, let's have a look at Reddit again. It seems like the best experience for users is to see depth of one thread. Like when a user posts like 20 level thread or a 30 level thread, you want to see the whole thread in front of you. But at the same time, you also want to see all the comments on the first comment. So all of these people, if I have to color them, the interesting ones here are in blue. And then you have the post also over here, so that will also be there. So most of the queries will come like this, get us post ID 123, let's say, and that will get you all the blue stuff. Okay, green won't be picked up in the first iteration. In the first API call, we will not pick up green. Later on, if you want to know all the comments here, you can dig that.
Correct.
So
till now,
yeah.
I think we've talked in a very simple terms that how it is going to look like. Maybe we can talk in terms of exactly what all data we're going to store with each of these nodes.
Okay, so let's look at post. Post has some metadata, and then it's got children. So whether we want to store that here or whether we want to put a parent link on comment to the post is a question. So it has got children, so I'll just note that down. It's got children. Apart from this, what else? Do we have anything else here? It has the number of likes.
Time. When you say metadata, timestamp, number of likes, and all that gets covered. I guess.
I should actually just call it content, because the post has it's got a title and all of that stuff.
Yeah.
I think it can be put in one place, but title and content is not something they're interested in. Like we said, it seems reasonably simple. It's just a variable inside. But the things we have to manipulate, time also we don't have to manipulate. Author doesn't change for us. The number of likes is something interesting. Keerti, should we look into this? I
think children would be more interesting to see first. Number of likes we can see later. Because likes is going to be sort of similar for comments or posts, the number of likes, basically. Interestingly, also, in Reddit, you can't even hover and see who all have liked.
Exactly. So it makes our life easy. You can see the number of likes, but you can't see who has liked which post. So if you store this as a count in a post, that's also good enough. There are no emojis here, like 5 types of happy likes, 2 types of sad likes, no, nothing like that. It's just number of likes. So this also makes it easy.
Maybe something like for a user, has the user itself liked or not, only that information would have to be stored. But that I guess we can discuss later, but that is not really important. But
yes,
we can focus on
that's necessary. Has this user liked this post? Yeah, we need that. Yes.
Yeah.
Okay, that's a good point. And apart from this, I think we also need a parent comment. No, posts don't have that. Okay, posts only have children. Let's get to
comment.
Yeah, comment. Comment is extremely similar. It's got the content. It doesn't have a title. It's got children, possibly. Number of likes, time, author, and it's got a parent. So the parent is either a post or a comment.
So this is sort of a two-way relationship. We are storing parent for children and children for the parent.
Yeah, since there are many read queries here, we can assume that the number of children don't change much. Even if they do change, it's easy for us to go to that object and make that change. If you delete something, then we can remove it from the children maybe, or we can just mark it as deleted. I think, Keerti, usually you are the kind of person who's like, don't get rid of any data, just mark it as deleted, and the UI can manage it, or the server will manage it. That makes...
Actually, in Reddit, that happens when you delete, you don't see it as deleted, you see it as this has been deleted. It is not like all the children will disappear. So you will actually see the post has been deleted. So for example, suppose in the diagram, can you see this? Suppose I delete this particular one. So it is not like these two should also get deleted or should disappear. Just the content of this particular comment will not be visible anymore.
Interesting. In fact, I'll put that then, deletion flag. And same with post. Maybe post doesn't need to have a deletion flag, maybe, or it could.
That would be, I'm not sure how that works, because if you delete a post, then what are you commenting on? But okay.
No, if you delete a post, we keep it just in case you have said something horrible, but nobody can see it. So we'll mark it as false. And the server, when it is reading any of this data, it just sees if the deletion flag is true. If it is, then it scrubs out all the data and sends you a blank. This post has been deleted, like something like that.
Right.
Okay. So when it comes to comment, the only interesting thing is children that I can see, and when it comes to post, I can see children. Comment also has parent. Yeah.
Yes.
This is also interesting.
So our diagram actually changes sort of, because here it is supposed to be both ways.
Yeah. You'll have this arrow come in a lot more. All of these comments will now have parents. So I'll just mark them in a different color. Maybe we can mark them blue. Okay. Yeah. Oh yeah. Okay. Bidirectional would have been so much easier.
Oh, you were not doing that. Okay.
No. I changed the color. In fact, the children won't be like pointers. The children will be a single array of pointers. So that would be more accurate. But yes.
Yeah,
now that we have
Yeah.
No, I think what's interesting now is we are talking about the access pattern where we are trying to get a post, and the post is getting all the children comments. So that can be retrieved in one go, just here. And if you want all the comments in a particular thread, then we need to have a concept of a thread. Right now, we don't have a concept of thread. We have, like over here, we will need to get all the children. And then we'll have to find all the children of this. But then how do you make a thread? Like, how do you make a straight line? Because this might have multiple children. Like over here, for example, should we pick this one or should we pick this one? Or this one or this one or this one?
Right. So level and thread ID is, I guess, what you're trying to say. There are going to be two important factors for every single node.
Yes.
So as we were discussing
what thread are you
earlier
part
as
of,
well.
and the index.
Yeah. So we can discuss that how each node would look like. How would you actually put the level and the thread ID, so that then we can discuss that how would the insertion, deletion, all of this would happen. So we have a clear idea of how things are working in this data structure.
Okay, let's just take both of these things then, and I'll just put it in comment.
Sure.
Because we need that. Level and thread ID. If you have, okay, let's see how this can work. Each comment has a level. When we are creating it, we are aware, which is like an index of a array list. So it keeps incrementing for a particular thread. Okay. So if we say that this is comment thread 1.
Maybe you can write T1 so that it is clear that you're talking about thread ID.
Yeah, sure. That can be T2, right? And then you have this as T3, 4, T5, T6, and T7. Okay, that's a lot of threads. But the good news is that we should be able to now get a thread straight, because when you say that get me a post, all you need to do is get all the children. Okay, but that's not enough, because once you get all the children, which thread do you pick? Do you pick T1, T2, or T3? If the post could have a thread ID.
There might be a lot of questions like among the people that how did we actually name this and all. We will discuss it in detail, guys. Like stay patient. Yeah.
Now if you get a query for post ID 1 to 3, how do we decide whether we should go for this thread 1 or 2 or 3? So either the post needs to have a thread ID, which would work. So then I would need to add a thread ID to the post. This would be the post thread ID, and that would simplify some things. Or we can remove this concept of thread from a post. And a post may not have children also. We can.
Why not though?
Yeah, no, I was just, okay, yeah. I don't know if a post should have a thread ID actually. Maybe a thread ID can be the post ID itself. I'm just wondering, why should that be a post?
Okay, I think we removed from here, but they can also be, instead of thread ID, we can basically have like a list of thread IDs. Do you understand? Like T1, T2, T3.
Yes.
Like for post,
Yes.
like how we have children. So basically, instead of thread ID, so children is there, right? Which is basically
Yeah. Thread IDs.
thread IDs. So yeah, for post itself, there is not going to be any thread ID, but children have thread IDs. So that helps.
We could, Keerti, we could have a thread ID here, which is the post ID itself, let's say. And so whenever you're trying to get a post, you just say, get me all the objects having this thread ID equal to post ID. So I'm just wondering over here, like, okay, let's say we want to get a post. Let's start there. We query the post table. We get some info. And at the same time, we go to the comment table, which is storing all of these comments. And we say, get me the post having ID equal to T1. So if the post ID was 1 to 3, then all of these thread IDs will be 1 to 3. And here we can change it. But then we can't auto increment. That won't be very nice.
Correct. So I think for simplicity, before talking about, how are we going to get and what all threads are we going to get, can we talk about what is going to happen when we add a new comment in any particular thread? How is this tree going to change, or how is the nodes going to change?
Okay, when we add a comment, let's go for a interesting node. Let's try to add a comment here. Okay, so at the end of it, we have a
so that will
comment.
Continue with T7, right?
It will continue with T7. Yes, you're right.
But if we add yet another comment on this T7, then in that case, we would need a T8, right? So we also need sort of an auto increment, which I guess you were talking about, to make sure that we have an idea that how many threads are there. Like for example, after this, suppose we add yet another one, which is suppose over here, right?
Okay.
For this T3, suppose I am adding. Okay. So that would become what? That would become T9.
T9 would be nice, yeah. Would be nice, sorry.
So
I guess we can have a unique, a UUID also. It really, nothing is stopping us from having a UUID here, because why should we not?
Yeah, but then we sort of need something to know that, okay, these are the children of that, which we are solving from this comment. We have the children, right? That, okay, T9 is the children. So we just keep a UUID. Yeah. That actually solves a lot of problems, right?
Yeah, maybe a UUID, and the post UUID can be used for the first thread, so that you can, get all the comments of that thread. But then, and then you need the children also. Okay.
Which is fine. You just keep the array or list of all the UUIDs of the children.
Right. And when you come here and you want all the children, again, you can get the array of comment thread UUIDs.
Yep.
Okay. Yeah, I think that would simplify, that does most of our job. Because whenever you're looking to, one thing that you mentioned is what if we are adding. This is one way where we can add comments. So the comment has a UUID, a comment thread UUID, which extends. Okay, when do we decide whether it extends or whether we have to create a new comment thread? We need to know the children of the existing comment thread. Yeah. So if there are no children, we give it the same comment thread. If there are children already, then we have to create a new comment thread. Okay, that also is then easy. So adding comments is simple. If we go to delete comments, if we mark as deleted,
which is very easy. We are not really removing the node. We are just removing the content and just updating this deletion flag.
Yes.
So just that on the front end, it will show that this has been deleted, but not any major change in the tree structure for us.
Yep. Okay. So we are able to add, delete, edit comments. We are able to, most importantly, we are able to search on comments pretty quickly. If you are liking a comment, we just go to that comment ID and add a like, increment that like counter. If someone is adding comments, so all this part is taken care of. Adding posts is taken care of. How do we store it in DB? In this way, we have children, parent, level, and thread ID. So when we are adding, we will have to say it's going to be added to this parent, and this is the content of the comment. It has no children right now. Author time we already know. No likes. Deletion flag is false. My parent I am aware of, like we said. Level is something we have to look at. I think level can be taken care of by the server. Do we really need a level here?
We do, right? Like
when we are adding.
basically
Oh
the
yes,
step.
yes, yeah.
Because yeah. Also, one interesting thing which I guess people might be thinking, that we are storing things two-way, right? That for parent we are storing the children, for children we are storing the parents. So we are basically not denormalizing the data, which I think we should just quickly talk about, that why are we choosing not to do that, just to make the queries faster and efficient, right?
Yeah. Keerti, just to clarify, I don't think we need the level, because parent, when we are adding, when we are retrieving, we might say that get me the level up to 30. But when we are adding, we already know the parent.
Yeah, but then we'll also know that at what level it is, right?
No, you don't need that, right? Because, so for example, if you have, you know that this is your parent comment, you don't need to mention the level. You just come over here and add it to the children, and you mark this as parent. Okay, the level would help, but the server will decide the level, I think.
Yeah, server will decide that I'm agreeing, that server will decide. But I'm thinking in terms of queries, that like for example, suppose I'm querying for this comment, and then say, okay, these many levels for that, suppose like 15 more replies, 20 more replies is how we get, right? So if we click on that, we will need level, right? That.
Yes. Yeah. Get us the next 10 levels, 20 levels.
Yes.
That will come from here. Okay, that makes the table very efficient also. Like you mentioned, Keerti, we are not denormalizing because we're having children and parent both. You could have a 3NF normalization where you have a separate table where every relation is noted separately. Don't want to do that. We don't want joins. Our access pattern demands that we keep everything together. Okay. One final thing then, how do we store this data? We know how to structure the data, but normally when we are getting any kind of query, we are getting it on a thread ID, set of levels, a number of levels. So let's say 10 levels, get me 10 levels for this thread ID. To speed that up, I think this is something we can sort on, so index on. And level is, we can get all the levels. Oh no, getting all the levels is also pretty scary. Maybe we can sort on this also. Let's see, a composite index might be in order. And we can shard on post ID, because keeping all the comments in one database may be too much, so we might have to shard. So on, yeah.
Coming to sharding on post ID, just pointing it out that some posts might have a lot of comments, some posts might not have a lot of comments, so they can be hotspots. But I guess it is fine. But still, there can be obviously workarounds for that as well, based on say number of comments for a particular post or the number of threads or something like that. We can multiply and use both and then shard accordingly. That is one way to go about it. Or to keep it simple for now, we can just shard on post ID.
Yeah. If you have like the count of threads tremendous, then there is Google Zanzibar. What it does is it initially shards on post ID or object ID, and later on it shards on a composite key. So we can say shard on thread ID if there are more than 50 threads or more than 1,000 threads. Yeah, that would work. Okay, one final problem, which is thread ID and index, thread ID and level both can't be indexed or both can't be used together in index. Should we have a composite key here? Thread ID level. I think so. Composite key would be, we write them both down.
Because from the starting we have been saying, right, that two things that identify a node, thread ID and level. So
and level,
makes sense. Yeah.
So with this we can easily first it will sort on thread ID, and those in turn will be sorted by level. So if you want to do a binary search for a thread ID, it will be efficient. And with the thread ID, if we mention the level, then again it will be efficient. So that is the index we are creating. And shard key is just on post ID. Very large ones, we will do thread ID also.
Correct. So the final thing remaining, I guess, is to see which database are we going to use to store this amazing tree that we have made. So multiple ways, right? One could be a simple document DB like MongoDB, DynamoDB, flexible as well, and we can shard, index, solves a lot of problems. Another way is also Cassandra, because we columnar databases can also be helpful, because thread ID level, our major queries are along that. What do you think is better?
Yeah, when it comes to Amazon DynamoDB or Cassandra, it's got this shard key, partition key. It's got index sort key, so we can use that concept, and life will be very easy. If you want to do it over SQL or GraphQL, firstly, don't do it over GraphQL. It's not necessary. We have already optimized for simple relational database. If you want to do it over SQL, that's also very much possible. But you have to manage the sharding and everything.
And also the scaling, because this is going to scale a lot.
Yeah, this is going to scale. The graph is something that is going to scale. SQL databases can scale, but you have to do everything for it. So rather just use a NoSQL database, which is giving off the shelf all the benefits. Plus, it's never going to, normally when you get a comment, you want to get the whole thing. So it's not going to be like, hey, I just want these columns. Just get the whole thing. It's okay.
Yeah. So okay. MongoDB and all do make sense, right?
Yeah. Very simple. MongoDB is good. Cassandra is good. DynamoDB works.
Yep. Great. Awesome. So this was very interesting, and we had a lot of fun. This looks very beautiful as well, the whole tree and stuff. Good job, Gaurav. And
thank you.
I hope you all had a lot of fun as well. And let us know if you want us to create any more videos like this, any more topics that you have in mind. We would love to add them to the series, and we hope you're loving the series.
Bye-bye.
See you next time.